For what value of A, the point with position vectors 6i cap plus 3j cap, 40i cap minus 8j cap, and ai cap minus 52j cap minus 5k cap are collinear. Okay, so let's try to understand the problem first. We'll consider 3 points. Let's say 3 points A, B, and C. These 3 points are collinear. Means that A, B, and B, C, if we join them, then all the 3 points A, B, C are going to lie on the same line. Now, what we'll do, we'll consider another point O, which is going to be the origin of a coordinate system. Now, with respect to this origin O, we're going to define the position vector of point A, point B, and point C. All we have to do is join point O and A with the help of a directed line segment. Similarly, we can join OB and OC with the help of directed line segments. So, let us suppose that the position vector of point A, OA vector, that's it, it is defined by 60i cap plus 3j cap. Position vector point B, let's say we're going to denote it by OB vector, which is given by 40i cap minus 8j cap. And then position vector of point C given by OC vector, so that's A times I cap minus 52j cap minus 5k cap. Fine. Now what we'll do, we will find out the vector AB. So AB vector, that's simply take OB vector and from it subtract OA vector. That means we are taking the position vector of the endpoint of AB, which is B vector, and from it subtracting the initial point, which is the vector OA. Fine. So we have OB vector given by 40i cap minus 8j cap, and from here we subtract OA vector, which is 60i cap plus 3j cap. So 40 minus 60, that's going to be negative 20. So we have negative 20 I cap, then we have negative 8j cap minus 3j cap, so that's going to be negative 11j cap. So this is our vector AB. We'll keep it aside for the time being. Now we will find out the vector BC. Now BC vector is going to be defined as OC vector minus OB vector. The OC vector, that's AI cap minus 52, J cap minus 5K cap. And from here, we're going to subtract OB vector, which is 40I cap minus 8J cap. Fine. Now that means we now have A minus 40. So this is going to be component of I cap. Then we have negative 52 plus 8. So that means we have negative 40 4 j cap, and we have negative 5k cap. So this is going to be the vector BC. Fine. Now in the problem, it's already given that these 3 points are collinear. So A, B, C are collinear, which means that, so let's write it down, since the points, since A, B, and C are collinear, that it immediately follows that AB vector must be equals to some scalar lambda times BC vector, where lambda is a scalar, some scalar value. Right. So we can substitute the values here. Now AB vector corresponds to negative 20 I cap minus 11 j cap equals to lambda times BC vector. So BC vector is going to be A minus 40 I cap minus 44 lambda j cap minus 5 lambda k cap. Fine. So now what we can do, we can compare both sides. On comparison, we get lambda times A minus 40. So that will be equals to negative 20. We're comparing the components of I cap from both sides. That's negative 20 here. And we have negative 44 lambda equals to negative 11. So there is no k component on the left hand side, so negative 5 lambda will be simply equals to 0. We don't have to worry about it. So here we have lambda equals to 1 over 4. So now we have the value of lambda. So let's substitute it here. So we have 1 over 4 multiplied to A minus 40 equals to negative 20. That gives us A minus 40 equals to negative 80, which gives us the value of A as 40 minus 80, that means negative 40. So now we have the value of A, so A comes out to be negative 40, such that the points having the position vector, these 3 vectors are collinear in nature.